Today we are going to study electrostatic potential. Electrostatic potential. But before studying electrostatic potential, we must know few fundamental things, and among those one is your conservative force. First, we understand what is conservative force. Conservative force. A force is conservative if work done by the force is independent of path. It means a force is conservative. A force is conservative means work done by the force is independent of path. A force is conservative means work done by the force is independent of path. Now, what is work done? We know from work energy power of 11th class that work done by a force is defined as work done by. Work is always done by a force. So work done by a force is the integration of the force dot dr. What is where your dr is small displacement vector, small displacement, and due to this force, small displacement due to F. If there is a force F and due to this force there occurs a small displacement dr, then this work done is your integration of F dot dr. Now if this force, if this F is conservative, if this force is independent of the path, it means if we write in terms of path, this will mean as work done from initial position. We can write Ri and Rf. Work done Ri to Rf is equal to integral of Ri Rf vector F dot dr. If this is position dependent, that is, it depends upon this initial position and final position. So what is here? Ri and Rf. Here your Ri is your position vector. Position vector of initial position. Likewise, what will be RF? RF will be position vector of final position. Right? So, here, if this force here, what is the difference between this and this? Here, it depends upon Ri, that is initial, and RF, final position. But here, no point of reference has been mentioned. That is, it is a general case, but if it is confined between two position, initial position and final position, and is independent of the path between initial and final position, then this will be a conservative force. So this is the definition of conservative force. This was your conservative force. Now we will study line integral of electric field. Line integral of electric field. Line integral of electric field. Now, what is line integral of electric field? So basically, if we say line integral, means electric field along a path. Electric field along a path or along a line. So how we would represent it? Suppose we have a charge at the origin. This is your x-axis, this is your y-axis, and you have a charge at the origin plus q. The path followed, suppose we have to find the line integral, that is electric field, line integral of electric field along a path, along a line. Suppose there is any arbitrary path like this. This is any arbitrary path, and this is your initial position, and this is your final position. This is your initial position pi, and this is your pf, final position. Let this is your position vector ri. This is your position vector rf. Suppose we have to find line integral for a small path. So we integrate electric field. Basically, electric field line integral means we have to integrate the electric field due to this charge from this point to this point. Suppose here the electric field at this point is this will be along this because it is unit positive discharge. Suppose this is your electric field and this is your, its position vector is your r, and this is r cap is your unit vector along this. At this point P, suppose this point is P, we have electric field E. Suppose from point Pi to Pf total length is L. So the length from Pi to Pf is your L. Now here consider a small length dl, this small length, this small length we consider dl. For this we have to first integrate. We know how to integrate. When we have to integrate, first we integrate for a small distance and then we will integrate it from initial to final. Now for small, suppose this point is your P dash, so here P dash is your dl. Now here electric field is along this direction, so as dl means infinitesimally small length, likewise this is, suppose this is your dr, this is your dr, this dr is along the electric field, that is small displacement along the electric field, and this dl is small displacement along the path. So we can write it as your dl is small displacement along the path, and dr is small displacement along the electric field. Here this is dr and this is dl, and suppose this is angle theta, this is angle theta between dl and dr. We draw a normal from P dash to Pn. So P dash to n. So P dash n is normal from point P dash on the line dr. So this is your normal. Now you have to find the electric field along this direction, along the whole length. To find the electric field, now we know that electric field E at point P is equal to 1 by 4 pi epsilon naught Q by R square, and its direction is along. So this is r cap, yeah, r cap, because this r cap is the position vector along the electric field. This is the electric field, and now this is dl. So line integral means what? Now come to the line integral. Line integral means we have to integrate the electric field along a line, along a path dl, along a path from what is initial position pi to pf. That is, this is your line integral. This is your line integral. So line integral means we have to integrate the electric field due to this point charge from initial to final. This is your line integral. Now we will calculate the value of this line integral. Now what is this actually? Pi to pf vector E dot dl is equal to Pi to pf E. What is your electric field? 1 by 4 pi epsilon naught Q by R square, and dr, sorry, it's not dr, it is r cap dot dl. So we have to find the value of this. Now one thing here, variable of how we will find this. So r cap, and r cap is along, see here in the direction, in the diagram, r cap is in this direction along electric field, and dl is along this, and angle is theta. So dot product, we know this will be initial position, final position, and 1 by 4 pi epsilon naught Q by R square. R cap is your unit vector, so its magnitude is unit, and dl and theta is angle between dl and r cap is your theta, so it will be dl cos theta, right? So this is your, now here it is constant 1 by 4 pi epsilon naught and q, all these are constant. Pi, pf, and 1 by r square, and dl cos theta. Now here variable of integration is dl, but the limit of integration lower and upper is your position. Now this is your R. The function is in the function 1 by r square. The variable is your R, and the variable of integration your is your dl. So how you will convert dl in terms to dr? Here we have to convert dl in terms to dr. How we will convert? See here. See, this is your dl along this, and dr is along this. So dl cos theta is itself a dr. This is your dl, and if you find the component of dl along this r, this will be dr. So dr actually is your dl cos theta. Because what is cos theta? Cos theta is your base by hypotenuse. If this is your theta, so here p dash n is your hypotenuse, and your pn is your base. So pn is your base. So cos theta is your b by h, and that's why here pn is your dr. Therefore dr will be dl cos theta. Dr will be dl cos theta. What is dl? dl is your p dash. In the diagram, see, p dash is your dl. So like this way we have got that dr is equal to dl cos theta. Therefore we can write instead of dl cos theta as dr. Therefore electric field, line integral of electric field, here dl cos theta we will put dr. So this will be your pi pf. But when we use pi, one thing here, your pi pf and 1 by 4 pi epsilon naught q by r square dl cos theta. So dl cos theta will be dr, and what will be pf and pi in terms of position vector? pi is your pi is for pi it is ri, and for pf it is rf. That's why the equation will become like this. That is line integral of electric field pi to pf will be actually ri from ri to rf vector e dot dr. and this will be your 1 by 4 pi epsilon naught q Ri to Rf 1 by R square dr. Now we will calculate the value. We will integrate it. So 1 by 4 pi epsilon naught. Here R to the power minus 2 and R to the power minus 2 plus 1 and Ri and Rf. You know the integration. Therefore, this will be 1 by 4 pi epsilon naught minus 1 by R. This is Ri and this is Rf. And this will be this will be 1 by 4 pi epsilon naught, here minus, so we can take minus 1 by R, Ri and Rf, and it will become 1 by 4 pi epsilon naught. We will write it as minus will be outside and 1 by Rf minus 1 by Ri, and if you you can write like this: 1 by 4 pi epsilon naught 1 by Ri minus 1 by Rf. This is your line integral. So we got that line integral of electric field is your position independent. That is, line integral of electric field does not depend upon the path followed. You see here, we are getting Ri and Rf, that is position vector. This is your Ri and this is your Rf, final, initial and final position. What is the path? It doesn't depend upon the path followed. So we can write that line integral of electric field, that is E dot dl, from initial position to final position is actually 1 by 4 pi epsilon naught. One thing is missing here, and it is your charge q. Q charge we got common, so here it is missing. So 1 by 4 pi epsilon naught q into 1 by r I minus 1 by r f. 1 by 4 pi epsilon naught Ri minus Rf Pi Pf, vector E dot vector dl. This is your line integral, which is path independent. That is, it doesn't depend upon the path. So this was the case of line integral. This is your line integral. Now we will see that line integral along a closed path. Line integral of electric field along a closed path is 0. This was your line integral of electric field. Now we will see line integral of electric field along a closed path is 0. This is your line integral of electric field along a closed path. This is your charge plus Q. This is your initial position Pi, and this is your final position Pf. We take two paths. One is like this. We name it as path P1, and again from this point, final position, we take another path and we reach Pi. So this is path, another path P2. Now electric field due to this will be, this is your Ri, and this is your Rf, final position. This is your path P1 and path P2. Now electric field is, we know that at any particular point, this is the direction of electric field. Here this is the direction of electric field. We have just studied that the line integral of electric field along a path is independent of the path and depends upon its position vector. So first we will find the line integral along the path P1, and then we will find the line integral along the path P2. So first